Event Video Playback is an add-on software package for the TwinCAT environment, which allows the creation of a video centered around a programmable event. This video can be viewed directly from the HMI log. This video demonstrates the installation and configuration of Event Video Playback. We will start with the installation section, and we'll be following the installation instructions on the GitHub Event Video Playback page. As this is a community source project, we have to first disable package signing verification for Package Manager. We do this by use of PowerShell. We can easily copy the command from the instruction page, open PowerShell, run as administrator, paste the command in, and execute. I will leave the PowerShell window open, as we will also use it to define the new feed for Package Manager. We will now use the online package feed installation method. We start with adding the package feed source to Package Manager. This is again done by copying the command and executing it in PowerShell. Select Yes to agree and continue. Next, we will install Package Manager workloads. As we are done with PowerShell, we can close it at this time. Open Package Manager. Required components are TwinCAT Standard, TE2000 HMI Engineering, and TF2000 HMI Server, along with TF7 TwinCAT 3 Vision. Next, we need to select the Beckhoff USA Community Stable Package Feed. Add the Event Video Playback Engineering and Runtime packages. And install the workloads. We can now close Package Manager. We are now ready to move to the Getting Started section. Event Video Playback consists of 3 items: the Video Playback Service, Video Playback Library, and the HMI Control. The Event Video Playback Service was installed when we installed the packages with Package Manager. Now we will go to the sample projects and download the HMI and PLC sample projects. In this instance, the file is downloaded to the default download folder. When download is complete, it will show in the upper right hand corner. Select to go to that folder. Extract the zip file. Cut and paste the example solutions to your TwinCAT solution folder. I recommend using a location closer to the root drive, as this will prevent errors with long file names. We will start with the Event Video Playback PLC example. Configure the real-time settings. In this case, we will be running our vision program on one isolated core. In this example, the router memory is configured to 1024 megabytes. If this value is too low, a message will be generated on program activation. Event Video Playback is already added as a reference library in this example. If this was a new project, Event Video Playback would be added via the Add Library function. Next, we will review the configuration required in the POU. All configuration parameters we discuss here are described in detail in the Getting Started section of the documentation. When instantiating the image to video function block, certain parameters are required. Camera name. This will be reflected in all log file entries and also serves as a subfolder to the video output directory for this instantiation. Frames per second. This is the rate at which images are entered into the image to video function block. Time before and after event. Note that this does not need to be full seconds. Reduction factor. By reducing the size of the image, the memory requirements and also the video storage area requirements are reduced. Here are some important router memory considerations. Higher frame rates require more memory. Longer videos require more memory. Larger images require more memory. Larger reduction factors require more memory. The Event Video Playback service configuration parameters are located in a file. That file can easily be navigated to by copying and pasting this location to File Explorer. These parameters consist of the video codec that is used in creation of the video, the ADS port, which should not be changed, and then the video delete time and max folder size. Each time a new video is created, any video that has a timestamp that's older than the video delete time in number of days will be deleted. Or if the folder size that's storing the videos is greater than the max folder size, the oldest video will be deleted. Library parameters. Please refer to the documentation for a detailed description of the setting of these parameters. Here I will show where those parameters are accessed for modification. Select Event Video Playback under References. Double-click Parameters Event Video Playback. This will open the editing screen for the parameters. This program example does not use file source images. It actually creates an image and embeds the system time of the engineering workstation on the image. Let's take a look at some of the important considerations of this program. The function block image to video is instantiated as EVP1. 4 different methods of this instantiation or library are called throughout the program. At startup, we call the reset method. That instills that the library is ready to start functioning. Moving on down through the code, we have the camera state control code, which is a universal code. Then we get into the section that creates the image. Then we get into when we have a new image that's within this if statement that starts at line 83. Notice there is a EVP1 add image method. So this adds the current image to the buffer. Then outside of that, we have the method, the cyclic logic call. This is called every time this task runs. It's required to let the library function properly. Then we also have methods for when an event happens. Notice there are 2 different method calls here which have different names for the log entry. This solution includes a visualization, which allows you to see that images are being created and to confirm that they are created at the intended image rate. You can also see the image number, and you can trigger either of the example events. Running only the PLC program, you will see the videos being created in the proper video location. Now we will activate the program. Generate trial licenses if required. Go online. And we can now see that images are coming in, and they are coming in at the proper rate, 10 images per second. Using ADS Image Watch, we can also view the current image being created. Note that this time will match the system time on your engineering PC. You can now trigger an event. And then you can also view the image at event display, which is the image that was present when you triggered the event. Using File Explorer, we can now navigate to the directory where our videos are stored and see that the video has been created and view it if we wish. Now that we have the Event Video Playback PLC solution running, we will log out, leaving it in run mode, and load the HMI solution. Open the desktop view. Expanding references, we can see that the Event Vision package is already installed in this example. This is the Event Vision control. If this were a new HMI project, to add it, you would open the toolbox, scroll down to Third Party, and find the Event Vision control. Drag and drop this to the desktop to add it. Let's take a look at the Event Vision control properties. There's three important settings that are made in here. Virtual drive, time zone info, and the video check retries. These are documented in the documentation and must be set for proper operation. Opening HMI Live mode allows us to see all functionality of this example except for the ability to view the video from double-clicking on the event log. So we can see the live image and we can trigger events in the live mode. Note that the system time and the image at most recent event match. Double-clicking on the event will bring up the details page, but as I mentioned before, we will not be able to view the video from live mode. Now let's look at publishing this HMI solution to an HMI server. First, we will need to configure the HMI server. Right-click on the TC HMI server icon in the lower right of the screen and select Service Configuration. The server shown is properly configured. Therefore, I will not add another server. I will simply go through the data entry that was required for the creation of this server. The name is for reference only. If I did not have a properly configured server, at this point I would add this server to my configuration. Now we will publish the HMI project. Right-click the project, select Publish to TwinCAT HMI Server. Double-click TC HMI Server. Change your publish configuration to Remote and expand virtual directories. Notice the Event Videos virtual directory. That matches with the desktop with the Event Vision control properties for the virtual drive setting. Validate the connection to assure that we have connection to the HMI server. and publish. When publishing completes successfully, it will automatically open a browser page to that HMI server. Password is 1. Note that the HMI server has connected to the running PLC project. We can see our live image. If we double-click on one of the log entries, at this time now the play video button is active and we can play the video that was created for that log entry. Selecting one of the events will cause a new item to be generated in the log. Notice now we also have the image at the time that that event was recorded. And then again, we can double-click that item and play the video. For reference, let's take a look at the HMI NuGet packages that are active for this solution. The package source should be set to Beckhoff offline packages. This is the usual setting. Thanks for watching. Please refer to the online documentation for additional info.